Okay, so in this video we're going to calculate upper estimate for this integral here, and it's going to be the modulus of this integral is what we're more interested in. So there'll be no negative values, we're just interested in the positive value. That's the first thing you'll sort of see there, obviously because it's modulus, and it's across the line of gamma, which goes from 1 to I. So first things first, let's just draw that on the graph. It goes from 1 to I, which goes there. And first thing we can work out is the length of this line here. Well, we're using simple Pythagoras. We've got 1 and 1. So basically square root of 1 squared plus 1 squared, basically square root of 2. So that's the length of this line here. So that's the first things first, that's good. We need to know that. Okay, so for upper estimate, how are we going to find the upper estimate of this integral? Now we're not going to do any integration. We're just going to break it down and find the maximum value of the top, the numerator, and the minimum value of the denominator. That way then we expand it up and get the best value we can. If we wanted the minimum value, we'd do the reverse. We find the minimum value of the numerator and the maximum value of the denominator. Okay, let's start with cosh of z. Let's see if we can find the maximum value of that. So what we do know is that cosh of z in exponential terms is 1/2 e to the z plus e to the minus z. That's what we know cosh is, that's the identity. So let's, working with this z values here, what's the maximum value z can be anywhere on this line integral? Well, the maximum value of z is going to be 1, isn't it? So z equals 1. That there is our maximum value. So let's just put that down for a start. Now let's work on this. So what we're looking for is the modulus of this as well. So we know that this is going to be larger than or equal to the modulus e to the z plus e to the minus z all over 2. Okay, let's work on this modulus a little bit more. So it is also going to be larger than or equal to, now we can go e to the z plus e to the minus z, and that's 1/2, put the half in front, bring that out front now. Technically we should put brackets on that, let's just break that down. So put the brackets there. Okay, let's put the 1/2 in. Do more work on this modulus as well. So that's 1/2 of e to the z plus e to the minus z. So already we're making progress here with this e to the minus z. The modulus of minus z is just going to be z. And what we're taking as our maximum value, z is 1. So this will then become equal to 1/2 e to the 1 plus e to the 1. So basically 1/2 of 2e, which basically equals e. So that's our maximum estimate for the numerator. Now we want the denominator. So for the denominator we need to use the backwards form of the triangle inequality. This is just the standard form. We need to try and find the backwards form now. So if we just take 4 plus z squared, so we know that this one, backwards form, obviously backwards sign on the inequality here, 4 plus z squared. Now what we do now, we got to break this down now. We bring the z squared out to the front and put the 4 in there with a minus sign. So now we go z squared minus 4. Obviously modulus of minus 4 now is just going to be minus 4. Power we can bring outside. So that's now going to give us z squared minus 4. Now what do we know what z squared is? Z squared is 1 squared. So it's less than or equal to 1 squared minus 4. Obviously we need to keep the modulus sign in all of this. And then 1 squared minus 4 is minus 3, which gives us, don't need this sign now, which basically equals 3. So the maximum value we've got now for the function is e over 3. E for the top, 3 for the bottom. So let's just write it like this for now. Just allow me to do that. 4 plus z squared. This one is going to be maximum value, so it's e over 3. So that's the maximum value, is e over 3, so it's going to be larger than this one, which could be less than, obviously. But now we introduce the length of the contour. So this one here, of gamma here, is square root of 2, which could calculate it earlier. So now what we can say is the maximum of integral along gamma cosh of z, 4 plus z squared dz is less than or equal to root 2 times e over 3. So we don't need this bit here now. This, that is going to be our answer. Okay, thanks for watching.